Gold isn't always locked away in solid rock. It can move, dissolve, and redeposit itself, creating rich new concentrations. Over millions of years, natural forces like water, weather, and chemical reactions work together to set gold in motion, breaking it free from its original source and sending it on a remarkable underground journey. This process, called supergene enrichment, takes scattered gold and concentrates it into easily recoverable deposits. It's nature's way of gathering tiny flecks and particles, sometimes invisible to the naked eye, and collecting them into layers or pockets that can be mined with much less effort than hard rock gold. Surface water seeps down, leaching gold from upper layers and carrying it deeper, where it reprecipitates when conditions change. This movement is driven by rain, groundwater, and even subtle shifts in soil chemistry, which can dissolve gold and transport it through cracks and pores in the earth. The result? A low-grade deposit can become a bonanza with a rich layer of gold just below the surface. These enriched zones can transform an otherwise unremarkable patch of ground into a prospector's dream, sometimes just a few feet beneath your boots. For prospectors, understanding this process means you don't have to find the original hard rock source, just the clues left behind. By reading the landscape and recognizing the signs of enrichment, you can zero in on areas where gold has naturally accumulated over time. These clues include subtle soil color changes, iron staining, and unique mineral assemblages. Sometimes a rusty red patch of earth or a cluster of unusual minerals is all it takes to point you toward hidden gold. Learning to spot these signs transforms prospecting from guesswork into a science. With the right knowledge, you can interpret the language of the land and uncover gold where others might walk right past. It lets you see hidden potential where others see nothing. The landscape becomes a treasure map, full of subtle hints and secret signals waiting to be discovered. So grab your gear. We're about to explore the fascinating world of supergene gold enrichment. With every step, you'll learn how to read the earth and follow the golden trail left by nature itself. Let's turn geology into gold and unlock the secrets hidden just beneath the surface. Supergene gold systems begin with a primary deposit, usually a low-grade rock where gold is present as tiny, often invisible particles. These deposits might not look impressive at first glance, but they hold the potential for something extraordinary. Over time, rainwater, naturally slightly acidic, seeps into the ground and reacts with minerals like pyrite, a common iron sulfide. This reaction produces even more acidic conditions, setting the stage for a remarkable transformation. The increasingly acidic water is now able to dissolve gold and other metals, carrying them downward through cracks, fractures, and porous zones in the rock. This movement is slow, but relentless, driven by gravity and the chemistry of the earth. As the water percolates deeper into the earth, it gradually loses its acidity. This change in chemistry causes the dissolved gold to precipitate out of solution, reforming as metallic gold particles in new locations. The result is a distinct vertical profile. At the surface, a barren, iron-rich leached cap forms, stripped of most valuable metals and stained with rusty colors. Beneath this cap lies the real prize, a gold-rich supergene blanket where gold has been naturally concentrated by these chemical processes. And even deeper still, you'll find the original unaltered primary deposit, often much less rich than the supergene zone above it. The supergene blanket can be many times richer than the original rock, making it a highly sought-after target for miners and prospectors alike. This entire process unfolds over millions of years, sculpted by the slow but persistent forces of weathering and groundwater movement. It's most common in ancient stable landscapes where erosion and tectonic activity are minimal. For prospectors, these supergene zones are nature's own gold concentrators, rich, shallow, and far easier to work than deep, hard rock deposits. They offer a unique opportunity to find gold close to the surface. Understanding how to read this vertical profile is essential for anyone hoping to discover the richest gold zones. It's a skill that separates successful prospectors from the rest. In the right places, nature has already done the hard work, concentrating gold and bringing it closer to the surface, just waiting to be found. All you have to do is recognize the signs, follow the clues, and let nature guide you to its hidden treasures. The hunt for supergene gold begins long before any digging starts. It starts with a keen eye for subtle surface clues that most people overlook. Experienced prospectors know that the landscape itself can whisper secrets about what lies beneath, if you know what to look for. One of the most important clues is the presence of gossans. These are rusty, iron-rich rocks with spongy or boxwork textures. Gossans form where sulfide minerals have weathered away, leaving behind a telltale iron-stained skeleton. Their unique appearance often marks the spot where valuable minerals once existed. Limonite is another key indicator. This iron oxide mineral can range in color from pale yellow to deep maroon, and its presence hints at the original mineral content of the rock. The richer and more varied the colors, the more likely you're in a promising area. Deep reddish browns in the rocks often signal the former presence of gold-associated sulfides, while lighter yellows are more typical of pyrite. These color variations are like a coded message from the earth, waiting to be deciphered. Don't overlook manganese oxides either. These appear as black, sooty coatings on rocks and are a strong sign of chemical alteration, especially when found alongside limonite. Their presence can indicate that the area has undergone the right kind of weathering for gold to accumulate. When you see heavy manganese and iron staining together, it's a powerful clue. This combination often points to hidden gold deposits lurking just below the surface, waiting to be discovered by those who know what to look for. Examine the rock's texture closely. Crumbly, weathered surfaces filled with quartz veinlets or boxwork cavities are classic signs of intense alteration. These features suggest that the rocks have been chemically weathered, which is exactly what you want to see in a gold-bearing environment. Intense chemical weathering not only changes the rock's appearance, but also helps concentrate gold near the surface, making it easier to find for those who recognize the signs. A well-developed gossan, with the right blend of colors and textures, is a prime target for further exploration. These rocks are nature's way of highlighting areas where gold may be hiding just out of sight. Learning to read these subtle signs takes practice and patience, but it's a skill that separates successful prospectors from the rest. The more you observe, the more the landscape reveals. The surface tells a story, if you know how to listen. Every color, texture, and stain is a clue in the search for hidden gold. By mastering these signs, you'll be able to find the gold that others walk right past, unlocking the Earth's hidden treasures, one clue at a time. Supergene processes leave a broad alteration halo. Color and texture changes in rocks and soil. Argillic alteration turns feldspar into soft clay, bleaching rocks white or pale gray. These clay-rich zones are softer, often forming subtle gullies or low spots, natural guides to mineralization. Watch for patches of pale soft rock chips and color changes in the soil. Iron oxides from weathered gossans stain soils red, orange, or yellow, creating visible fans downhill. A sudden shift to richer soil colors means you're close to mineralization. Quartz float is another clue. Gold-bearing quartz is rarely pure white, often stained rusty or reddish. Sugary or chalcedonic quartz textures are common in these systems. Collect and examine quartz types. They reveal the nature of the hidden deposit. Reading these subtle changes is key to zeroing in on gold. The landscape is your map. Follow its clues. You don't need fancy equipment to find supergene gold, just the right tools and sharp observation. A sturdy rock hammer is essential for breaking rocks and exposing fresh surfaces. A gold pan lets you quickly test soil and rock for heavy minerals. Practice panning. It's the fastest way to spot gold in the field. Digging tools like a shovel, trowel, and pickaxe help you reach different soil layers. Quality tools save time and energy, letting you sample efficiently. A hand lens is vital for examining minerals up close. Use a GPS or mapping app to record sample locations and keep a detailed notebook. Document everything: rock types, colors, and panning results. Your notes and samples become a treasure map, guiding your next moves. With simple gear and careful records, you're ready to uncover hidden gold. Once you spot promising surface signs, it's time to dig and sample. Trenching gives you a vertical cross-section, revealing soil layers and the contact with bedrock. Dig perpendicular to the mineralized zone, aiming for 3 to 4 feet deep or until you hit bedrock. Watch for color and texture changes as you dig, especially the transition from leached soil to saprolite. Saprolite often hosts the richest gold. Take systematic samples from each layer, labeling them by depth and location. Pan each sample, looking for gold and heavy black sands. Even without visible gold, a spike in heavy minerals signals you're near a gold zone. Keep meticulous records of your results. Comparing samples from different depths and locations builds a 3D picture of the enrichment zone. This methodical approach pinpoints the richest layers. Dig smart, sample carefully, and let the data lead you to gold. Modern prospectors have powerful new tools, AI and portable analyzers, to boost their odds. AI-enhanced gold maps use geological data, satellite imagery, and mineral databases to highlight high-probability gold zones. These maps reveal subtle alteration halos invisible to the naked eye. For individuals, access to these tools means smarter, more focused prospecting. Portable X-ray fluorescence (PXRF) analyzers give instant chemical readings of rocks and soils. While PXRF can't detect gold directly, it finds pathfinder elements like arsenic and copper, confirming you're in the right spot. Use AI maps to pick targets, satellite imagery to spot anomalies, and PXRF to test rocks on site. But remember, technology guides you, but fieldwork finds the gold. Swing your hammer, dig your pits, and pan your samples. The best results come from combining new tech with classic boots-on-the-ground prospecting. Finding a supergene deposit is just the start. The real reward is recovering the gold. If gold is in soft saprolite or clay, simple hand tools and a sluice or dry washer can do the job. Break up clay to free fine gold particles. Supergene gold is often extremely fine, mustard gold, and can be hard to recover with basic methods. Advanced tools like spiral wheels or shaker tables help capture this fine gold. Always work methodically and responsibly, excavate only what you can process, and follow all regulations. Backfill your pits and leave the land as you found it. Responsible prospecting protects the environment and the community's reputation. The search for supergene gold blends science, hard work, and discovery. With the right knowledge and tools, anyone can find their own bonanza. The gold is out there, go find it.